Students, today we will study about the generation and the conduction of nerve impulses. You know that the nerve impulses are conducted through axon, and axon has a membrane outside which is called as the axolemma. Inside the axon, the exoplasm is filled. I have shown here the membrane, and exoplasm is filled, and then again the complete membrane here is present. So outside this axon, extracellular fluid is present that contain the ions like sodium chloride, potassium ions, and inside the membrane, that means in the exoplasm, what is present? Ions are present, potassium ions, and proteins are also present here over here. So, and this neuron has got some channels, ion channels, as well as the pump also. And these ion channels are of three type. I have told you earlier, leaky channels, and they don't have the door, anything can pass through them easily, and they get open and close randomly. And then these are the two type of channel for the sodium as well as potassium. Then voltage gated channels which have the doors in them, understand, and they are just able to open because of a particular potential difference, voltage they open. And there is a sodium potassium ATPase pump also, which we will talk later on. So here what happens, how there are the three stages of axon while conducting a nerve impulse: resting potential, depolarization, and repolarization. And what is the resting potential and what type of polarity remains here? Here the axonal membrane is positively charged outside and negatively charged outside. Why happens so? Because of the three reasons. Differential membrane permeability. Membrane is more permeable to the potassium ion. Membrane is more permeable to the potassium ion, and the outside in extracellular fluid, number of sodium ion is always more. There are the three sodium ion, and which have been made after the repolarization through the sodium potassium ATPase pump, and two potassium ion inside, understand. So sodium is always more, and here the potassium leaky channels open, they remain open, and through which the potassium leaks outside. So number of positively charged ion is always more outside the axonal membrane as compared to the inside in the intracellular fluid. That makes the axonal membrane positively charged from the outside and negatively charged from the inside. And not only this reason, sodium ATPase pump is also operating, which is working against the concentration gradient, and this is putting the three sodium ion outside, and two movement or inward movement of two potassium ion inside. Again, there is the difference in number of the ions on the outside, that means extracellular fluid and in intracellular fluid. And third reason is these proteins are present which are negatively charged, and these, because of the larger size, they can move through these channels, and they will remain near the membrane, positively charged membrane, and that will again make it negatively charged from inside. So resting potential, membrane potential here is when measured minus 70 millivolt. That is why it is the negatively charged inside, and positively charged outside. Okay, so here no stimulus is being conducted, membrane is just resting, no work is being done. The second stage comes the depolarization, and in the depolarization what happens? Sodium channels get open. The sodium channel, leaky channels are open, and these, what will happen? Because of these sodium channels are open, so sodium will move inward from outward. Sodium move continuously inward, and that will change the membrane potential from -70 to -55. And when -55 potential difference occurs, that is called as the threshold intensity, and that is needed for the action potential. Now what will happen? These sodium channels which are voltage gated, they will also open. The sodium voltage gated sodium channel will open, and because of opening up these voltage gated sodium channel, there will be more influx of sodium. Understand? Movement of sodium inside, and it will make now changes. It will change the polarity of membrane. Instead of being positively charged, now membrane is negatively charged on outside and positively charged on the inside. Why? Because you can see here there are the more sodium ion, and here the less sodium ion, and number of potassium ion, voltage gated potassium channel remain close here. Then what will happen? When action potential is obtained, the polarity is changed. Here the charge is positive charge, negative charge, here positive charge, and here the negative charge, and here positive charge. So it will just complete the circuit, and this electrical disturbance is now becoming the stimulus for conduction of the impulse. And what will happen further? When the polarity is because of the entrance of more sodium inward, the polarity becomes here the reverse, my negatively charged outside and positively charged inside, and potential difference will become the plus 30 millivolt. Understand? And this stage is called as the depolarization, and here inward movement or influx of sodium occur due to opening up more sodium leaky channel for the sodium and voltage gated sodium channels. Then there comes another stage called as repolarization, because there is a difference created in the number of ion inside and outside. Here there is more sodium inside and less sodium outside, but here the what is done now? The potassium channels are open, voltage gated potassium channels are open, and that they will cause the movement of sodium to the movement of potassium outside. Understand? These sodium voltage gated sodium channels are closed now, and potassium channels which are also voltage gated